Guys, if you're checking this out, that's awesome. This is an unlisted video that's going to talk briefly about the code that was used to power the DIY time-lapse cart that I've recently posted on YouTube. So the idea here was just to make a video that was going to go through all of the code that was used so that if you are getting confused, you're getting stuck on something, just to kind of go through it and explain what I was thinking and what I was doing when I made it. And, well, it also will help if I ever end up going back and trying to figure out what I was doing. So this is kind of for you and for me. First bit here is just a bunch of comments about all the different parts that were used. You can see, if you wanted to see the original video, it's there. All the parts that were used, blah, blah, blah. You got the Arduino Nano. We got the motor driver there. There's a different one that I found here that's like $6 versus mine, which was like $30. So if you can figure out how to make this one work, I think it works exactly the same way, but that would be the much cheaper option. The one I was using was kind of overkill for this project. This is the four-wheel drive robot base. There's tons of different robot bases available. You do not have to use this one. Lots of local hobby shops and model shops will have them. Or you could even just go get an old RC car and modify it, or then you just basically are figuring out how to use an Arduino to control the motor or the motor driver that already exists on that thing. So that could be a really fun project, and that might be something that I take on a little bit more in the future. And then we talk about the electronic components that were used. So it's just the resistors, and potentiometer, the momentary switch, some LEDs, the perf board, the power switch, the battery holder, and some hookup wire. A little bit about what kind of tools you need, but I'm assuming if you're doing this, you've probably got most of these around. And one other thing, guys, do not buy cheap side cutters. These ones here, these guys right here, these are Knipex side cutters. These things are awesome. If you, well, they're pricey, but they are absolutely amazing. These are the things to get. Like, the problem with side cutters is they wear out quick, and you only use them for little leads on electronic devices. Like, never use them to cut real wire. Just use them for cutting off those little leads. But you want good ones, because once you're doing this for a while, you're going to get really frustrated if you get shitty ones. So buy the good ones. Those are the best, and those are the ones to get. But again, they are pricey. So if you're just starting out, maybe find something cheaper. But when you invest in them, you want to get something like that. And now we get down into the code itself. Now, I've done my best to try and put comments on everything so that even if you're just a beginner, you understand what this does. But basically here, this is just to include the Arduino library. Now, because I'm using Atom and Platform IO to do my programming, I need to include this. If you are going to be programming through the Arduino IDE, you're just going to want to put 2 comments in front of this, because the Arduino IDE automatically includes that. And you may end up with an error where it's trying to include it twice. So just, if you are getting that error, just comment that out and your life will be much easier. And then this constant initializing, this is just telling the Arduino what pins are going to do what. So these constant initialize speed input, we're just basically giving names to different Arduino pins. So this is constantly initializing the speed input as the analog pin A1. And we're just going to do this. So this is going to be the input from the potentiometer, and then we're going to continue going down. So we've got an input from, or this is going to be actually an output. This is going to go to the PWM pin on the motor driver, and then these 2 pins on the motor driver are just direction pins. So that's Arduino pin 4, 5, and 6 are just going to be used to control the motor driver. What is important when you're doing this is to make sure that you're actually using PWM pins for pins that require PWM functionality. So I know that pin 5 on an Arduino Nano is a PWM pin. Not all pins on Arduinos are PWM pins. So you might just have to look up a data sheet and see which pins are PWM, and then make sure that a pin like the PWM control for the motor driver is indeed a PWM pin on the Arduino. So that's why it's pin 5, and that's why this order looks a little bit messed up. Then we come down here, we've got a couple more pins to initialize. We're going to initialize a button pin. This is what's going to, our momentary switch is going to be attached to. And then we initialize our LED. So this is our indicator LED. And we have to connect that via 500 ohm resistor. Otherwise, we're just going to burn the LED out, because we are powering it via 5 volts. So depending on what color you are, you can use some online resistance calculators for figuring out what size of resistor you need, but 500 ohms for most things you do on a Arduino connecting LEDs to it works fine. Now we need to create some storage values. So these values here, these are basically just empty containers in which we're going to store values. And this is what we're going to be able to put. So read value, that'll be the value we get from our potentiometer. The write value, now because when our Arduino reads an analog input, it gets a value from 0 or from 1 to 1023. But it cannot output that many stages of PWM, so it can only output 255 stages of PWM. So the reason there's a difference between the read value and the write value is that we have to map the 123 to 255. And then there's a button state, so this is what's going to keep track of whether or not our push button's been bumped. And then there is the count. So this is going to be the count indicator that we use in our loop later on. And then there's this PWM speed, and this is just going to be used to accelerate the cart at a, well, not just suddenly turn the motors on, so it's actually going to be used to accelerate it slowly when it's in intermittent mode. So now we come down into the void setup. This is basically just setting up all the pins. So we see here that we just basically set pin modes of the speed input to input, and then PWMs, and these things get set to output. And this just lets the Arduino know what pins are going to need to be inputs or outputs. And then that brings us down here into void loop. So this part of the program is what's going to run forever. So as soon as once it goes through all this setup stuff, which is when it starts up, and then it enters void loop, and it's going to stay there until the device is powered down or reset. So this first statement here in the void loop, this if statement here, this is what's going to run to check and see if the button's been pressed. So it says if digital read button pin. So that's going to check and see if the button pin is high. If it is, it continues. If it isn't, it bumps totally out of this loop and just continues on. So as soon as the button's not pressed or it's low, which is what the state of that button is most of the time, it's just going to skip everything past here and just keep on going through the program. But if it has been pressed, so that means that it's high, it then decides whether or not the button state is high. So this is just basically keeping track of whether or not the button was pressed before. So if it is high, it writes button state to low, 0, and if it's low, it writes it to high. So this is just basically saying that if we're in intermittent mode, switch to continuous mode, and if we're in continuous mode, switch to intermittent mode. And then there's this little while loop at the end here, and this is super, super important because this is what's going to make sure the program doesn't continue running while the button is being pressed. And the worry with that is that if you do allow the program to continue running while the button is pressed, you're going to end up looping back through here and just continuing to switch these two back and forth. So your button press isn't actually going to do what you're expecting it to do. And depending on how delays work later on in this program, it may not even be possible to get different modes. So basically this just says, well, digital read button is high, delay 10. So until this Boolean operator here, which is digital read button high, is false. So until the button's released, it's just going to continue looping. So if you hold the button down, the program will hang here forever until that button is released. And as soon as that button is released, this value drops to low, this Boolean operator becomes false, and the program moves on. So these two lines here, this is just digital writing the INA and INB pins to high and low. This doesn't matter what you write here. This just controls which direction the motor driver goes. So depending on what motor driver you're using, or depending on which direction you want your cart to go, you can play around with these values and get the cart going in whichever direction it is you want. Then we come down to read value, analog read speed input. So this is basically just setting the value of read value to whatever the analog read of speed input is. So this just goes and finds out what the potentiometer is set to and sets read value to that. And now we come to the divide in this program where we decide if we're going to be in intermittent mode or in continuous mode. So the first thing to check is if button state is 0. So this goes back to this loop we had up here. So the default for this, when the program boots up, when the Arduino starts running, button state is always 0. So it will initially start up in continuous mode. So that's this part of the program right here. So this goes if button state is 0. Okay, so now we're into continuous mode. digital write the LED low. Okay, so that's going to turn off the LED to make sure that we know that we're in continuous mode. Then it's going to create the write value as the mapped value of read from 0 to 123. So there we define what the values possible for read value are to 0 to 255. So that's the output possibilities of the PWM pin. So we've just mapped all the values in between 0 to 1023 to 0 to 255. And that just makes sure that whatever input value is going to correspond to the appropriate output value. And then we go ahead and we analog write PWM, which is our pin, with the value of write value. So whatever value we've created in write value from mapping the read value, we then write that value to the PWM pin so that the motor controller knows how fast to run the motors. And then we just have a short delay of 50 milliseconds to allow the program not to trip over itself. And then basically that's it for the continuous mode. So all the continuous mode does is every 50 milliseconds, it goes ahead, it checks to see if the button's been pressed. If it hasn't been pressed, it just reads the value from the potentiometer, and then it just maps that value and writes it to the motor controller, and it just continues doing that until you press that button or you power down the controller. But what if button state is not equal to 0? So what if we've pressed that button and we've changed button state from 0 to 1? Well, that means that this part of the if statement, from this closed bracket, or from that open bracket to this closed bracket, isn't going to get run. The program instead is going to skip right down here to else. And then it's going to run through basically all the rest of the program. So it's going to start by digitally writing the LED pin high. So that's going to turn the LED pin on to let us know that we are in intermittent mode. And then again, it's going to map those read values. But this time, instead of mapping them from 0 to 255, as it did up here, it's going to map them from 0 to 10,000. And this is because we're going to be using them instead of PWM outputs, we're going to be using them as a time delay. So we want to make sure that when it's 0, it's going to have no delay, and when it is 10,000, we want to, or when it's maxed out, when the potentiometer is maxed out, we want to be able to have up to a 10-second delay between pulses. If you want to make your DIY time-lapse cart go even slower, you could increase this to 30 seconds or 50 seconds or however long you want it to go. But you could go to a couple minutes as your max delay if you really wanted a super, super slow time lapse. With that value mapped out, we come down here to this while loop. Now this while loop exists simply to allow the controller a nice soft start. So we don't want the motors just going straight to whatever power level they're at. We'd like them to ramp up slowly and turn off slowly. And this just means that the cart's not going to bounce around as much. You're not going to have a chance of it getting out of line. You're just going to have a nice soft start. So basically, this while loop is going to run while PWM speed is less than whatever the maximum speed you want to set in. So in this case, I found that basically the maximum speed I want the cart to get up to when it's pulsing is 80. So that's 80 out of a possible 255. So if 255 is max speed, I'm just going to go from 0 to 80, and then I'm going to go back down. So what do? I write PWM. So that's my pin, PWM speed. And right now, PWM speed is 0 because we set that at the start of the program. All right, so we got PWM speed of 0. So we write that. Then we wait 1 millisecond, and then we say PWM speed is equal to PWM speed plus 2. So next time it runs through this loop, instead of writing 0, it's going to write 2. Next time through, it's going to write 4, and then it's going to write 6. And it's going to continue doing that until the PWM speed that we're going to try and write is going to be larger or equal to 80. Now, if you wanted this to accelerate more slowly, you could increase the delay between each time it runs through this program. So you could increase this number. And if you want it to accelerate faster, you can increase this number down here. So if you want it to accelerate very, very quickly, you can make this number about a 10, so that instead of going through this program once and just only adding 2 every time, it's going to be adding 10. And then there's a delay function. So this is how long you want the cart to continue running after it's reached its maximum acceleration speed of 80. In my case, I found that I really don't want it to stay at speed for very long. So I've set this to 0, but again, if you wanted to change yours, you can. Or if you're using a different kind of platform that maybe accelerates more slowly, or if your gearing on your motors is lower, these are the variables that you'd want to change to make sure that your car works the way you want it to. So with that, we then come into our deceleration. This works exactly the same way. In fact, it's the same loop as this well loop. Instead of waiting until PWM speed is larger than the set value, it just waits until it is, well, larger than this minimum value. And again, down here, PWM speed, instead of increasing every time it runs through the loop, is decreasing. It's not a guarantee that the PWM speed variable is going to leave this well loop at 0. It's just a nice safety measure to make sure that the motor controller is actually set to 0 when it goes into its delay between pulses. And that delay between pulses is handled by this well loop right here. And this well loop is a special well loop because it has 2 variables that need to be satisfied. So basically there's 2 separate Boolean operators. There's this one here, and there's this one here. And these 2 and signs mean that the only way this well loop's Boolean operators can be satisfied is if both this and this are true. So the first one is digital read, the button pin is low. So this just makes sure that if you decide while the program is running and while you're in intermittent mode, you decide that you would like to exit intermittent mode and go back to continuous mode, this makes sure that if you push the button while you're at a delay between the 2 pulses, the program will still exit and allow you to go straight back into intermittent or to continuous mode, even if you're in the middle of a very long delay. So that's just kind of a safety measure so that you don't get stuck out and you don't keep pushing the button wondering what's going on. And then the second part here is well count is less than the right value. So this basically just means that every time we go through this loop, every millisecond we go through this loop, we're going to add 1 to our count variable. And until our count variable is larger than our right variable, which is how long we wanted to wait, which we figured out up here with this mapping of the read variable. So once this right variable is smaller than our current count, or once our count is larger than our right variable, we're going to exit this well loop. So we basically go through here and we have a delay of 1 millisecond, and then we add what's this plus plus, which is basically just adding 1 to our count variable, and then we loop back through. And we do this, like I said, until this becomes untrue. And once it does, we exit the loop, we reset our count variable to 0 so that we're ready to go for our next pass through this program. And then we end this, we close off this if statement. So this bracket closes up there, and we then end our program and we loop back to the start of void loop to continue through this program 1 more time, and actually, well, kind of forever. So that's how the program works. That's how everything is set up. It's probably not the simplest way to do it, but that's how I did it. I am by no means a proficient programmer. I can get through coding most of the time, but I am not amazing at it. So if you see something I've done wrong, you can definitely go ahead and leave it in the video comments below this, or if you've got different ways of doing it, leave those down there. But if you have been getting confused, I hope that this was a clear enough explanation of how it all works and what all the different things do. Guys, if you've enjoyed this video, hit like. You're probably already subscribed because there's not much of a chance you'd be seeing this if you weren't. But until next time, thank you very, very much for watching.